The procedure of hypothetically reconstructing architectures from the past that no longer exist or were never built requires making subjective choices. To aspire to produce 3D digital models with scientific value, it is necessary to keep track of these choices and communicate them clearly and transparently. The goal is to ensure that future users will be able to verify the procedure and potentially confirm or contest it. Good documentation should allow anyone to reproduce the same results by following the described procedure. However, not all future users will study the appended data in the same way. Scholars will consult all attached metadata and paradata. Nevertheless, this may not be the case for someone who will look at the reconstruction in informal contexts, such as museums, video games, or documentary films. For this reason, it is crucial to find an effective and immediate way to communicate the level of reliability of the reconstruction to avoid feeding misconceptions and misunderstandings that could give rise to historical falsehood over time. The scale of uncertainties is one of the most commonly used strategies to prevent these risks in the field of hypothetical reconstructions. In this context, it is defined as an analysis and visualization system aimed at quantifying the level of accuracy, coherence, and historical plausibility of the reconstruction, based on certain related data, such as the sources used. It's often structured as a sorted multi-level list, where each level corresponds to a specific degree of uncertainty, accompanied by a brief text defining the rule with which it is assigned. Each level is also identifiable by a unique color assigned to the various elements of the reconstructed model. A model represented in false colors, if provided with a legend, will allow future users to understand at a glance which elements are more or less uncertain. Over the years, numerous scales based on different approaches have been developed. For example, some measure the uncertainty based on the sources used or some of their characteristics. Others follow a more subjective approach based on fuzzy logic, or others consider the quantity, age, or quality of available archaeological remains. In some cases, characterized by greater complexity, more than one scale has been used to assess different characteristics of the same model. Or it has even evolved into multidimensional matrices, such as the one known as the extended matrix, often used in the archaeological field. Although the objectives are the same, not all proposed solutions are equally effective. For example, sometimes scales are ambiguous, too subjective, inaccurate, difficult to apply, or even misleading. Therefore, in the context of the COVER project, we have defined good practices for creating new uncertainty scales. An effective scale must be reusable, exhaustive, unambiguous, and objective. Reusable means that it should be applicable not only to the project for which it was developed, but also to other projects. This characteristic promotes the comparability of results in different case studies. Exhaustive means that it must be complete for the context in which it was developed. It's important to design a scale with all the necessary levels to cover the widest possible variety of cases, even if not all levels are used in the study project. Adherence to this principle improves the reusability of the scale. Unambiguous means that the scale should be clear both regarding to recognizability of colors and clarity of textual definitions. This characteristic is important for improving readability as well as its applicability. An ambiguous scale would contribute to producing different interpretations both in the analysis and in the fruition phase, an aspect to be avoided in a scientific context. Objective means that two different operators that are asked to analyze the same hypothetical model should be able to independently produce comparable results. This characteristic is possible only if the definitions of the various levels of uncertainty are designed with attention to avoid overlaps, and if the assignment of these levels is based on a user-independent criterion. The uncertainty scale, developed for the critical digital model and refined in the COVER project context, it's based on these principles and will be further explored in another lesson. It has proven effective for analyzing, quantifying, and visualizing the uncertainty of reconstructions of never-built or lost architectures, and has been further developed and refined for its use from the architectural to the urban scale. This solution is certainly not the only one possible. However, aspiring to develop an approach capable of quantifying the uncertainty that becomes systemic even if only for certain categories of reconstructions is crucial for improving the readability, comparability, and reusability of models, published in a shared scientific environment.